Hello everyone, I am ZEROVIRO. Thank you for joining me today. Hydrogen produced via water electrolysis is an increasingly important energy carrier in the global push for clean energy and meeting the world net zero targets. However, the hydrogen gas generated through electrolysis is not pure. It contains moisture, oxygen, nitrogen, and potentially trace contaminants from system components. Even in the most advanced proton exchange membrane or alkaline electrolysers, the output stream contains moisture, oxygen, nitrogen, and even trace metals. These impurities may seem minor, but their impact is significant. In fuel cells, they reduce efficiency. In pipelines, they cause corrosion. In storage and transport systems, they introduce safety hazards. The answer lies in purification, and this is where pressure swing adsorption steps into the spotlight. Invented by Charles Skarstrom in 1959, pressure swing adsorption technology began industrial use in the 1960s. It quickly gained ground because of its simplicity, efficiency, and adaptability. Before entering the pressure adsorption system, contaminated hydrogen enters the deoxo unit, typically containing a few ppm of oxygen. In deoxo unit, the gas stream passes through a catalyst bed, usually made of platinum or palladium on alumina. In the presence of the catalyst, hydrogen reacts with oxygen to form water vapor. The reaction is exothermic, so temperature control is important to prevent catalyst degradation. The resulting water vapor is then removed downstream using the pressure swing adsorption. Today, pressure swing adsorption is capable of delivering 99.999% pure hydrogen, that's 5 nines. It operates at ambient temperature, requires low energy, and recovers up to 90% of hydrogen, making it a workhorse of the hydrogen economy. So how does it work? Pressure swing adsorption operates on a simple but powerful principle. Different gases are adsorbed differently under pressure. Hydrogen passes through microporous sorbents like zeolites or activated alumina. Impurities such as water, carbon dioxide, and oxygen stick to the surface. Hydrogen, being less strongly adsorbed, passes through. When the sorbent becomes saturated, pressure is released, and the impurities are flushed out. This cycle repeats every 1 to 10 minutes in continuous operation. 2 or more beds operate alternately, one adsorbing, the other regenerating, ensuring an uninterrupted flow of clean hydrogen. Among all the contaminants, moisture is one of the most critical to remove, especially for proton exchange membrane fuel cell applications. Water vapor causes degradation of the membrane. It lowers the performance of the system, and it increases the risk of corrosion in storage and pipeline infrastructure. For this reason, pressure swing adsorption is also used specifically for gas drying, sometimes paired with temperature swing adsorption for large-scale operations or dual-bed systems for continuous drying. Pressure swing adsorption. Pressure swing adsorption operates at ambient temperature and varying pressure. It is a low energy consumption. It produces high purity level of hydrogen, requires less investment and lower operating costs. The materials used are less expensive. Fewer processing steps, resulting in cost savings. Long operational life, up to 30 years reported. No deactivation or poisoning issues with sorbents. Let's not forget the regulatory side. ISO 14687 is the gold standard for hydrogen purity, and alignment with SAE J2719 for mobility. These standards are not optional, they are essential. They protect sensitive systems like fuel cells. They ensure safety in domestic and industrial use. They form the backbone of certification and grid integration. Meeting these standards requires precision, and pressure swing adsorption enables us to do just that. As we build the hydrogen economy across mobility, heating, storage, and power, purification is not a luxury. It is a necessity. And among all purification technologies, pressure swing adsorption remains one of the most cost-effective, scalable, and robust tools in our arsenal. From its modest invention in the 1950s to its essential role today, pressure swing adsorption reminds us that sometimes, the simplest ideas have the most powerful impact. Hydrogen purification, particularly gas drying, is a cornerstone of hydrogen system design. Adhering to ISO standards like ISO 14687 ensures compatibility, safety, and performance across a wide range of hydrogen applications. As hydrogen infrastructure grows, whether for transport, residential heating, or grid energy storage, robust purification technologies will become increasingly critical to system reliability and global decarbonization efforts. Thank you very much for your time and watching my video. Really appreciate you sticking around until the end. Awesome! If you found this video helpful, please share it with your friends and give it a big thumbs up. And don't forget to hit that subscribe button so you never miss future videos like this. Got a question or a topic you'd love me to cover? Drop a comment below, I'm always excited to hear from you.